in short, given our two previous assumptions, to prove the existence of free disposal equilibrium is equivalent to prove the existence of a price system P star and a vector of excess of demand Z star, such that Z star belongs to Z of P star, to the intersection between Z of P star and the non-positive ortant of the n-dimensional Hilbert space. This means simply that in Z of P star it's sufficient to find an excess demand vector with all non-positive components. While in the original definition only the null vector was admitted. In this case we admit also any non-positive vector, because this implies the existence of equilibrium in a proper sense. Is it clear? Now, by means of the same properties as before, strict variance law and free disposal, we can prove a fundamental result, well-known fundamental result. If in equilibrium for a good there exists a negative excess of demand, according to this definition, then the price of a corresponding good in equilibrium must be equal to zero. In other terms, if in equilibrium the good I, according to Van Ras, is superabundant, there is an excess of supply which is destroyed by the firm with the free disposal technology, the price of that good must be equal to zero. The good must be free, gratuitous. How is it possible to prove this theorem? Simply by using strict variance law. It has right variance law in an extensive form. This vector must verify as all the other vectors this equality. Sorry, let us use another K. K. Because I is the good which has a negative excess of demand. Isolate the I term of this sum. You obtain P star I times Z star I plus sum for K different from I of P star K times Z star K. And this must be equal to zero. It's simply an algebraic step. But in equilibrium, all prices are non-negative. All excess of demand are non-positive. So, this sum is a non-positive term. And therefore, in order to have zero, this term must be non-negative. But since Z star I is a negative number, in order to have this result, it is necessary that P star I is equal to zero. In this case, in particular, this term is zero, this other term is zero, and so on. However, the proof is this. I repeat, write the strict variance law, isolate the I term of this sum, you obtain clearly this result. But remember, we are in equilibrium. Every price by free disposal is greater or equal to zero, and by definition, every excess of demand is less or equal to zero. So this sum is a non-positive term. And therefore, since the sum of these two is equal to 0, this term must be greater or equal to 0. But since z star I are assumptions a negative number, the only way to verify this condition is that p star I is equal to 0. Huh? In conclusion, as I told you a moment ago, if in equilibrium a good is superabundant and not scarce, as in Varras, then its price must be equal to 0. That good must be gratuitous, free. Note that if Varras' law were not verified as an equality, less or equal, then the result does not hold. It is possible that a good is in excess of negative excess of demand, excess of supply, but its price may be a positive number. Because in this case, since Varras' law is not verified as an equality, this means that there is at least a subject which is locally non-saturated and so on. And therefore, this is the reason, because we have a free good with a positive price. Well, the theorem is very simple. I prove this theorem also in the undergraduate course. To conclude, an important observation. Since every subject is a maximizing one, it maximizes preference or utility if he is a consumer, or profit if he is a firm, the demand and supply correspondences are homogeneous of degree 0. You remember from the first and second part of the course from Pacini and Salvadori, since behind the choices of our subjects there are maximizing behaviors, then for every P and for every positive lambda, dH of lambda P is equal to dH of P, and SF of lambda times P is equal to SF of P. This is homogeneity of degree 0 in economic terms, absence of monetary illusion, a well-known property. But this means that if P star is an equilibrium price system, every other price system like this, lambda times P star with lambda positive number, is a positive number, is another equilibrium price system. Consequence of this observation, we can restrict in the search of equilibrium, we can restrict our attention only to the price system which belongs to the unit simplex of the n-dimensional Euclidean space. What is the unit simplex? You remember, surely, the definition of the unit simplex. Consider this graphic. Here there are prices. Suppose that there are only two goods. Well, the unit simplest denoted by large delta is nothing but the set of all the price systems, non-negative price system, such that the sum of the components of P is equal to 1. The unit simplest, which is clearly a set which has this form. Why can we restrict our attention to the price system which belongs to delta, and we cannot consider all the other price systems? The reason is obvious. As before, suppose that this price system is an equilibrium price system. You can reduce all the components of P star by a suitable lambda, positive lambda, in order to obtain another price system which belongs to delta. And by what I told you a moment ago, also lambda times 2 star is another price, equilibrium price system. So, in order to find equilibria, it's sufficient to consider the elements of delta. In other terms, we can normalize the price vector to pass from P star with components P1 star P star M to another vector in which every component is divided by the sum of the components of the same vector P star. If you divide any component of this vector by the sum of the components themselves, you obtain an element of delta. Simply lambda is equal to 1 on the sum. This is possible since by our previous assumptions all prices are non-negative predisposal, and at least one price must be a positive number by assumption of inexistence of Bliss points. And therefore, I repeat, we can concentrate our assumption on the elements of large delta. But why? Because large delta is an empty, convex, obviously, and compact set. In order to prove the existence of equilibrium, the compactness of a set of relevant price systems is fundamental in order to apply the fixed point theorems. The real reason to restrict our attention to delta, large delta, is simply this. So, after another break, I shall rigorously enunciate these fixed point theorems without demonstration, because it is excessively complicated, and then we can begin to prove the existence of equilibrium by starting from the simplest case of univocal choice.